Yes, I'm going to start today's lesson, that is D and F block elements. D and F block elements, okay? Together we are going to read about D and F block elements. First we can say about D block. Yes. D block elements, also known as transition elements. D block elements also known as what? Transition elements. Why we are called them as transition elements, we will learn, okay? And these D block elements lies between S block and P block. Between S and P block, between S and P block, D block elements are arranged. Okay, between S and P block, D block elements are arranged. This is one reason we are going to call them as transition elements. And another reason is these D block elements exhibit more number of oxidation states, and also because of these oxidation states, they are going to exhibit color property. Okay, this is another reason. The first reason is D block elements are arranged between S and P block, and also another one is all these D block elements are exhibiting colored property, and also they can show more number of oxidation states. Okay, they can exhibit colored property. Colored properties, and another one is more number of oxidation states. Oxidation states. Different oxidation states are going to shown by D block elements. That means while showing the different types of oxidation states, the electrons are going to be excited and de-excited from one energy level to another energy level. During that period, the transitions are going to absorb some energy. Okay, so maybe some visible region, IR region, like that. At that time, these elements are going to show color property. Okay. Next one, their general electron. How can you identify the particular element is D block element? You all know very well that is the differentiating electron enters into the D orbital, that is known as D block element. Differentiating electron enters into the D orbital. Differentiating electron enters into the D orbital, then we can call them as D block elements. D block elements. The differentiating electron enters into the D orbital, then we can call that element is the D block element. D block element. So how can you identify the particular differentiating electron enters into the d orbital? By knowing its general outer electronic configuration. See what is that general outer electronic configuration? N minus 1 into D 1 to 10 electrons, and Ns 1 to 2. the differentiating electron enters into the d orbital. That particular element comes under as d block element. And to identify this one, we should need to know about its electronic configuration. That is n-1 into d, 1 to 10, ns 1 to 2. That means maybe d orbital will have only one electron, or maybe two electrons, or maybe three electrons, or maybe 5, 6, 7, 8, 9, 10. Okay. Here few exceptions are there. Few elements comes under as D block, but we should not tell them as transition elements. What is the reason? We should know. Okay, and then here if you check, those elements are zinc, cadmium, and mercury. Zinc, cadmium, mercury. These elements are comes under as D block. These elements are comes under as D block, but not transition elements. These are not transition elements. These are not the transitional elements. What is the reason? Anyone of you know about this one? Because the transition name, because of their nature, colored nature. If D block is incompletely filled, I mean D block, the element present in D block, if it is having incompletely filled D orbital, then we can say it is a transition element. Because of incompletely filled D orbital, the electrons are going to be transmitted from one level to another level. At that time, in that particular region, they are going to absorb energy, so that they can show colored nature. But if once the element is having completely filled d orbital, that is not going to be involving transitions, dd transitions from one energy level to another energy level. That's what they can't able to absorb particular I mean energy in particular region. That is the reason these three elements are not going to be I mean comes under as a transition elements there, because of they don't have colored nature, colored property. Because due to, I mean, behind this one is they are all, I mean all these three elements are having completely filled d orbitals. Okay, here I'm writing completely filled d orbitals is the reason. Completely filled d orbitals is the reason to not have transitional property. Okay, transitional, I mean those are not comes under as a transition elements. Okay, because of completely filled d orbitals, no transitions are possible in these elements. So no color absorption of some wavelength in some region. That is the reason colored properties not there for these elements. No colored property. Okay, so this is the main reason. Completely filled d orbitals. That is the reason these are not comes under as transition elements, but these are comes under as d block elements, because here 1 to these all these three elements electronic configuration comes under as D10 configuration. Okay, D10 configuration. Here completely filled configuration is nothing but D10 configuration. So remember these exceptions. Okay, yes, the first one is D block elements are also known as transition elements. Yes, these D block elements are arranged between S and P block. That is one reason to call them as transitional elements. And also another reason is those are all, I mean all D block elements are going to be absorbed some wavelength in a particular region. That's what they can able to show color, different colors. That's what we can call those are having colored property. That is another reason to call them as a transitional elements. And another one is another reason is they can show more number of oxidation states. Okay, these three are the reasons to call them as transitional elements. Their general electronic configuration is n minus 1 into d, 1 to 10, n is 1 to 2. Maybe in s orbital, maybe one electron or maybe two electrons. In d orbitals, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 10. Okay, yes. But zinc, cadmium, mercury, if you check these three elements are not comes under as transitional elements, but they can comes under as d block elements because these three elements are having completely filled d configuration. Because of this reason, electrons transitions are not happening. If electrons transitions are absent, then they can't able to absorb wavelength some particular regions. So they can't able to show color nature. That is the reason we can't call them as a transitional elements. Okay, yes. Here if you check d block elements, divided into series: 3d series, 4d series, 5D series. These three series are completely filled series. Okay, complete series. Okay, but the 6D series is there. 6D series is there. That is incompletely filled series. Incompletely filled series. 6D series is what? Incompletely filled series. That means by seeing this one, we can conclude that D block elements are divided into four series. First series is 3D series, next series is 4D series, and after that third series is 5D series, and the next one is 6D series. 3D, 4D, and 5D series are completely filled series, and 6D series is the incompletely filled series. So please make a note, all of you, all these points, then we will go to next page. Everything is clear till now? Students, my audio, video, whiteboard, everything is clear? Yes, thank you. Vivo. Okay, again and again you are saying Vivo, Vivo, Vivo. Dana. Kada? Your Vivo means Dana. So from today onwards, Dana's name is Vivo. It's not Dana. Am I right? Hmm? Okay, I'm going to next page. Yes. I receive one message. Ha 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 ha. Avunu, ha ha ne. Your name is Vivo. Hmm? Yes. Next one. 3D series is what? First series of the D block. 3D series is what, my dears? First series of the D block. First series. Is it visible, Vivo? Huh? 4D series is second series of D block. 5D series is third series of D block. 6D series is the fourth series of D block. Okay, yes. These three are completely filled series. These are all complete series. Complete. These are all complete series, but this one is what? Incomplete series. Incomplete. Incomplete series. So if you check 3D series, scandium to zinc. Okay, this incomplete series is the actinium is the starting element. So this is incomplete one. Okay, we are not discussing about which one is the last element. Okay, next. Yttrium to cadmium is the 4D series. Yttrium to cadmium is the 4D series. Okay, this is yes, it's scandium. Scandium to zinc, yttrium to cadmium. So if you check 4D series, I mean 3D series elements, what are those? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Here, 5D series, the starting element is lanthanum and the ending element is the mercury. Okay. Yes, these are all 4 series of D block. Okay. Yes. If you check individual electronic configurations of all these elements, scandium. Before that, checking electronic configuration, what are their physical properties? Physical properties are these are all transitional metals. Okay, except here zinc. Except zinc, remaining scandium to copper. These are all transitional metals. So generally, metals are showing malleability or not ductility. General properties, metals are having malleability, ductility. Ductility meaning is what you already know, all these meanings. Okay, so I'm not writing those things again. So here, scandium. Scandium atomic number is 21. So it's electronic configuration as the general electronic configuration I told you in previous page, N minus 1 into D 1 to 10. 1 to 10, NS 1 to 2. So you can follow this order. This is 21. So here the nearest noble gas, argon. So N minus means if you check its completely complete electronic configuration, the last shell is here 4s shell. Okay, argon 4s to 3d 1. This is the outer shell electronic configuration of a scandium. So in d orbital only one electron is there. Next, if you check titanium, its electronic configuration is 22. Argon, this is 4s2 3d 2. Vanadium, argon 4s2 3d 3. So next one, chromium. Chromium's atomic number is what? 24. Its electronic configuration is argon. See, remember, this is exceptional one, 4s1, 3d, 5. 4s1, 3d, 5. Why I am writing like this? We will discuss after finishing this electronic configuration. Okay. Manganese, 25. Is there any doubt? I received 2 messages. Which one? 4s2, 3d5? Yes, manganese 4s2, 3d5. Okay. 4s2, 3d5. Good, very good. I didn't check your name. Later I will check. Okay. Iron. Iron 26. What is its electronic configuration? 4s2 3d6. Okay. Cobalt. Cobalt. Argon I'm not writing. Okay. 4s2 3d7. Nickel. 4s2 3d8. Copper. 4s1 3d10. Can we write like this? Yes, we can. Next, zinc. 4s2 3d10. Clear all of you? So here the observable things are two. What are those ones you check? Here it is chromium's electronic configuration and copper's electronic configuration. Okay. Copper atomic number is how much? 29. This is 30. Okay, this is 28. That's 7. So listen here, chromium and copper electronic configurations are not excited state electronic configurations. These are ground state electronic configurations only. But we are writing like this. Why? I mean 4s1, 4s1 3d5, 4s1 3d10 because the reason is here completely filled and half filled. Okay, here it is half filled configuration and copper is the completely filled configuration. Copper is the completely filled. Both half filled and completely filled configurations are there. The element gets more stability. That is the reason here, without excited state, without excitation, for copper and I mean chromium and copper, we are going to show like this only. And another reason is the less energy gap present between 4s3d in chromium and 4s3d in copper. That's what easily the electron enters into the d orbital. So here we are not saying it is excited state electronic configuration. We are saying it is ground state electronic configuration is configuration due to the stability reason. Okay, if it is half filled configuration, it is more stable, and also if it is fully filled configuration, then that one also more stable. So please, all of you, take a screenshot. Screenshot all of you, if possible, note all these points. Any one of you have any doubt, please let me know in my message inbox, message box. You can chat box, anything. Ritika, are you sleeping till now? Hmm? Please note all of you. Vivo V2 111. Who's this girl? Huh? Only Vivo. Vivo 1901. Vivo Pro. Madam Tinnara. Vivo is asking me. Mobile అడుగుతుందమ్మా నన్ను. మేడం తిన్నారా? మేడం ఇంకా తినలేదు. మీ క్లాస్ అయినాక తింటారు. మరి మీరంతా తిన్నారా? తిన్నావా అవంతిక? వెరీ గుడ్. నైస్. యశస్విని తినలేదంట. ఫినిష్ అయిందమ్మా. సో వీడియోస్ ఆన్ చేస్తారా అందరూ? ఇంకా ఓన్లీ 4 minutes ఉంది. నేను న్యూ టాపిక్ స్టార్ట్ చేసిన మధ్యలో ఆగిపోతుంది. వీడియోస్ ఆన్ చేస్తారా? మాట్లాడుకుందాం కాసేపు ఒక 2 minutes. చేశారా? వెరీ గుడ్. దివ్య తేజ. నైస్. పెట్టు, ఆన్ లో పెట్టు, ఏం కాదు. మనమే ఉన్నాం కదా, ఇక్కడ ఎవరు లేరు కదా. ఆ ధన దొంగ. నేమ్ పెట్టుకోలేదే? ఎందుకు నేమ్ పెట్టుకోలేదు? ఆహా. ఇంకా ఇంకా ఎవరు? దివ్య తేజ కనిపించట్లేదు నీ ఫేస్, విండో తప్ప. గుడ్. స్క్రీన్ షేరింగ్ స్టాప్ చేయనా? మీరు అందరు కంప్లీట్ అయితే స్టాప్ చేస్తాను నేను. కంప్లీట్ అయిందా తల్లి అందరిది? ఓకే. వైష్ణవి, ధన, ఇంకా బి వైష్ణవి ఆన్ యువర్ వీడియో. రితిక, అవంతిక. ఇంకా ఇంప్లిమెంటేషన్ ఎగ్జామ్స్ రాస్తారా మీ అంతా? మీకు మేడం పెట్టారు కదా బెటర్మెంట్ ఎగ్జామ్స్ నోటిఫికేషన్ గ్రూప్ లో పెట్టారు. కంప్లీట్ చేసావా? వెరీ గుడ్. కానీ నేను స్టాప్ చేయలేదు స్క్రీన్ షేరింగ్. ఎవరైనా ఇంకా చేయని వాళ్ళు ఉంటే చేసుకోండి, ఎందుకంటే 2 minutes లో ఎండ్ అయిపోతుంది మీటింగ్. అందరూ ఆన్ చేయలేదు వీడియోస్. అందరూ ఆన్ చేయలేదు. మీరు నేనేగా ఉన్నది ఇక్కడ. స్టాప్ చేయనా షేరింగ్? నాన్న స్క్రీన్ షేరింగ్ స్టాప్ చేయనా? అయినా ఓన్లీ 25 మెంబర్స్ ఏంటి ఈరోజు? అందరూ బయటికెళ్లారా? వీకెండ్ కూడా కాదు కదా! రేపటి నుంచి కదా వీకెండ్. హ్మ్. ఓన్లీ 25 పీపుల్ ఆర్ హియర్. ఏమైంది?
ఓన్లీ
ఇప్పుడు 23. స్క్రీన్ షేరింగ్ స్టాప్ చేస్తున్నాను. హ్మ్. చెప్పండి. 1 మినిట్‌లో ఎండ్ అయితుంది మీటింగు.